Well, good morning, everyone. How are we doing today? Please do say hello in the chat. It would be great to hear from you and know that people are actually watching and interacting. I see there are 41 people, 43. Okay, so we have some concurrent viewers, but it'd be nice to know that people are actually there and not just their computer is logged in. Lovely, lots of people saying hello. Fantastic. Hopefully this will help with a sort of sense of interactivity, etc. A few things that we should say. So, first of all, on the course website, I have posted some updates that relate to the ongoing pandemic. We are transitioning. So this week we had labs that were in person, and some of you still have to do your labs. So we had labs on Monday and on Tuesday. I should say about the labs, some people had a bunch of trouble with things like web browsers not working properly, etc. And people had problems with their computers freezing and locking up and having to be restarted, all of that kind of thing. You'll be happy to know that through the efforts of a wide range of people, we have managed to identify what the underlying fundamental problem is, which is good because there could have been like 5 different things, and actually fix it too. So the labs for the rest of the week, you should not experience those problems. You should not experience the limitations that people had on Monday and Tuesday. It is unfortunate that the Monday crowd ended up being sort of guinea pigs. However, the good news is that this brand new lab that had never been used before, which has quite a lot of shiny computing equipment in it, is now going to work properly. So hooray! The process of debugging this involved all kinds of bizarre steps, like having 12 computers all showing the different lecture videos at the same time. And what I've learned about myself by listening to myself giving a lecture, 12 different times is I say a lot when I'm lecturing. So I'm going to try to do that a lot less, and we'll see how that goes. So, that sort of thing. But yes, we did manage to isolate the problem, and it turns out it had to do with the video drivers. We have we have moderately nice video cards in those computers that can support all kinds of useful activities, like supporting artificial intelligence and machine learning courses in higher levels, that sort of thing. And it turns out we had a problem with the video card driver. So now that that's been fixed, hooray. But yes, so that is a long-winded way of saying we are transitioning to have more and more in-person activities. So people are now doing in-person labs, and starting next week, many of you are also going to be taking lectures on campus. Not in this course. In this course, we're going to continue with remote lectures because we have more than 100 people. However, lots of you will be on campus and attending lectures in person, and also using things like study spaces. And it looks like we're probably, I previously said we might be able to. Now it's looking pretty sure, but it's not official. It hasn't been signed off. It looks like we'll probably be able to use EN 2006 during our lecture slot to show the lecture stream. So if you're on campus, you'll probably be able to just go to the room that I would normally lecture in and sit and be with 20, 30, 40 other students who are also watching the lecture while giving yourself lots of room to spread out, because that room holds a lot of people. So as we're doing more in-person things, labs, lectures, etc., there are a few things that would be great for you to think about. If you don't have a booster shot yet, but you're eligible on campus, you can get these things. Again, I mentioned in the last lecture, please do consider the COVID Alert app. And there's also a rapid test. I did it again. There's also a rapid testing clinic that exists in the landing. I had a rapid test on Monday before I started interacting with people in the lab, and it was negative. And that's something that you can also avail of. Now, I have no idea how long this is going on, if it's happening all semester. I don't know what's going to happen when thousands of students show up next week, if everybody's going to be able to continue getting them. I can't make any promises there, but I do know that that rapid testing clinic exists now, and it's a helpful thing. So it's something you might want to consider. Okay, lots of good mornings and hellos and stuff still coming in. That is wonderful. So today we are going to continue with... I'm really sorry. All of that time I was not showing you my screen. The thing that I was trying to show you was this news item. Of course website, news, COVID updates, booster shots, COVID alert, rapid testing, and the overflow lab slots. So these are all different things that we can use to try to keep each other safe, to have the most pedagogically meaningful, so have the best learning experience we can possibly muster, while also trying to keep people safe from this pandemic. So let's talk about Python scripts. So remember last time we were talking about Python variables, and we said that variables in programming are in some ways a little bit like mathematical variables, but they're also in very important ways different from mathematical variables. Let me ask you a question now in Top Hat about mathematical variables. No, I don't want to assign it as homework. I want to present that. There we go. So hopefully this question won't be too taxing, but we'll see. And we'll get our thinking caps on. Yeah, lots of answers coming in. That's good. I'll give us another few seconds and then I'll close this one. Close it maybe 5, 4, 3, 2, 1, and closed it. And again, it will be open again as homework later if you didn't get a chance to get in. There we go. So most people did indeed have the right answer. If I declare that x is equal to y plus z divided by pi, x is the same thing as y plus z over pi. If I say that y is 2z, if I say that z is pi, well, that means we can substitute back into previous things. So wherever we see z, we could put pi. So y is 2 pi, x is y plus pi over pi. Y we said is 2z, so it's 2 pi, which means this is 2 pi plus pi. 3 pi over pi is 3. So that is indeed the correct answer. Good. So that's thinking about mathematical variables. And we went from, but in programming, variables are a little bit different. So we went from using variables in Python, such as taking a variable that someone else has defined for us called radius, or taking a variable called analog reading, and this pertains to the lab that some folks have done and some folks are still yet to do, or taking variables named things like R1 and R2. There's a nice Star Wars reference for you. R1 and R2, and using those in mathematical expressions to evaluate some more complex value. Well, we've gone from using variables to defining variables. So now we are going to tell the Python interpreter, please create a variable called radius and initialize it with this value, circumference divided by 2 pi. Or create a variable called frequency and initialize it with the value that you get from the expression on the right. Or let's create variables called R1 and R2 and initialize them with the values from the expressions on the right-hand side of the assignment statement. So, just to review, mathematical variables, if we say that h is 15 over 4 times t, then more people saying good morning. Very good. So if we say that mathematical variables are, here's a mathematical variable, and if h is 15 over t, then here's a question that you can just answer in Top Hat. What's h when t is equal to 20? Again, this is going to be pretty straightforward, I hope. Okay, so we've got one answer here, which is 3. We've got another one, which is 75. Okay, we've got lots of 75s in there, right. So let's try this. If t is 20, then 15 divided by 4 times 20 is indeed 75. Very good. But now, let's say that I tell you that t is 0. Well, in that case, what is h now? Maybe I don't need to keep my calculator around for that one, hey? Right. So at first I tell you h is 15 over 4t. Then I tell you that t is 20. Okay, well then I guess that h is 75. Later I tell you, well now t is 0. Well, that means that h is indeed going to be 0. So that's fine. So h is a placeholder, and h can always be substituted for 15 over 4 times t. Oh, that's interesting that lots of zeros came in the chat, which is good, but one of them in particular elicited an emoji reaction of dynamite or firecracker. Interesting. It's always interesting to me when people use, okay, now we're going to get a whole bunch of emoji piling onto that one specific response, aren't we? Okay, that'll make somebody feel good, like, yes, you really are quite the firecracker. Someone said they can't see the question. So that wasn't a Top Hat question, sorry. That was just something you could type in the Top Hat chat. So that wasn't a preset question to be answered, and that would show up in the gradebook. If we're thinking about variables in programming, things are a little bit different. So in this case, I've said... Actually, I should put my face away so that you can actually see what's on the slides. Let's say that we have a variable which is r. Now, if I say that frequency is defined to be 0.3 times r plus 300, so what can we do? Let's initialize a variable called r with the value 100. Now, I'm going to say that I'm going to initialize a new variable called frequency and assign it whatever the result of 0.3 times r plus 300 is going to be. And by the way, what will the type of that expression be? 0.3 times r plus 300. What do you think the type might be? There's a couple of plausible answers, so don't worry if you get the wrong one. Right, so it's probably going to be either int or float. The actual answer is... So you can see that this variable holds 330.0. So if I say, what is the type of the value stored in frequency? It's a float. And that's going to be for reasons that we explain in a little bit more detail later. But when we have mathematical operations like this that involve floats and integers, the result becomes a float, because a float can represent larger values, smaller values. It can represent more values. It can represent things that integers cannot represent. So here we have r has been defined to be 100, and then frequency is 0.3 times r plus 300. So now let's say that later we, after doing some other stuff, change the value of r to be 0. Now in this case, what is the value of frequency going to be? Yeah, okay, there's some controversy here. So when I change, and perhaps the controversy is because there's a slight lack of clarity around what exactly I mean. What I mean is that here I am going to, I've typed in r equals 0, I'm going to press enter, and then I'm going to print out the value of frequency. What value will it print out? So there's some controversy as to whether it'll be 300 or 330. And the answer is, when I change the value of r by pressing enter here, that only affects the variable r. It is not changing anything to do with other variables. And this, I know I'm belaboring this point because we've talked about it before, but it really is a crucial point, and sometimes people forget this and then they end up in terrible scrapes. So here I defined a variable called r, and remember, a variable is just a place in memory to hold something. And so that variable I started by storing, what did I store in it? 100. And then we defined another place in memory to hold a frequency. And we initialized that with an expression, 0.3 times r plus 300. So to evaluate that expression, so we initialized that with 0.3 times r plus 300. So how did we evaluate that expression? Well, did we do the multiplication part first or the addition part first? Which comes first? Order of operations in this case is the same for Python as it is for mathematics. The multiplication, right. So we did this part first. So 0.3 times r. Well, how do we evaluate 0.3 times r? Well, 0.3 times whatever value is currently in r. How do we find out what the value in r is? We don't go back and look at other Python statements. We don't go back and look at other stores of knowledge about what values are stored where. We simply look in the box. Now, if that seems very simplistic, it is, but that is the way that the computer works. And so if you try to solve the problem in a different way from how the computer does, you'll get a different answer. And remember, now we're not doing math, we're doing programming. So r is 100. So 0.3 times r is 30. And then we can do 30 plus 300. And then that gives us the number 330. So far, so good. So we took an expression on the right-hand side of an assignment statement, and we used it to initialize our variable. Then I come along and I execute another statement where that statement is r is assigned by 0. And what does that do? Well, that erases whatever value used to be held in r, and it replaces it with the number 0. But we did not change any other variables. All we did was put another value inside of r. So that means that when I come along here and I print the value of frequency, I'm still going to get 330.0. So unlike the mathematical operation, when we were doing this with math, we said that this is a statement of fact, that h is always equal to 15 over 4 times t. And then later I said, suppose t is this, suppose t is that, suppose t is something else. But in programming, statements that assign values to variables, the order matters. And when we reference the value of a variable, all we do is go to the place in memory that holds the value, and we look at what is the value currently held in the box. So someone says, but frequency remains the same. Yes, absolutely. So I changed the value of r. That doesn't do anything to the frequency. And so some people found in the lab that if you're trying to read a value like r from, say, taking an analog reading on your Grove kit, so perhaps you read an analog value from this little potentiometer, this rotary resistor here, variable resistor. You read a value of r from it, and then you calculated a frequency based on that, and you played that on the buzzer. When you twist the knob here, that doesn't change the value of r. The only thing that changes the value of r is reading from the analog sensor again and storing it in r. But even when you do that, it doesn't change the frequency that you're playing over the buzzer. In order to change the frequency, you have to assign a new value to the frequency variable. So, a variable in programming is a place in memory that holds a value. And that place is initialized by assignment statements, variable name, single equal sign, expression, and it is also updated by assignment statements. So when we have, let's see, I'll create a variable called x equals 3.14. And then I want x to hold something different, x equals 0. Or sometimes we'll say x is assigned by, to be really, really clear that we're not talking about equality checking, which would be like the equals, double equals sign. If I want to say is 0 equal to 1, well, that is a comparator. Like we said, is 0 greater than 1. Remember, these comparator operators that we can use in expressions. So two equal signs, that is checking to see if two things are equal. A single equal sign means we are assigning whatever's on the right-hand side, just 2 times 3, whatever's on the right-hand side, we're assigning that into the variable named on the left. And so those assignment statements look the same. Oh, sorry, I should put that away. Those assignment statements look the same whether we're creating this variable for the very first time or whether we're just changing the value that is held in a variable. So last time I asked you to do some exercises. So I said, let's define some variables. And I'm not going to do all of these right now, but define a variable, holding a value of one of these types, and then change it to a different value and check the type each time. So here are some sensible examples. So I've created a variable called x, and it holds a value which is an integer. Then I'm going to assign a new value to it. My favorite variable name. There we go. And now we can see that the new value inside of x is a string. So x used to have a value which was an integer. Now it has a value which is a string. So, strictly speaking, in Python and many other languages like it, variables don't have types. The values held inside of variables do have types. This is different from some other programming languages. If you've learned C++ or Java or Rust or I think Go or some other languages, the variable itself can only hold values of a certain type. Python doesn't work that way, and lots of other dynamically programmed languages like Ruby and, well, lots of languages don't behave that way. So a variable doesn't have a type, a value does. And you can put different types of values into that variable. We put an int into x, then we put a string into x. So when someone says, as shorthand, because it's more convenient to say, when someone says, so what's the type of that variable? In Python, strictly speaking, the variable doesn't have a type, but what we mean is the type of the value that's currently held in that variable. So when someone says, what's the type of that variable? You don't have to say, well, technically there is no type for a variable. No, you know what they mean. What they mean is that what's the type of the value held in that variable. And so here are the types that we have used thus far. And you can play with these things. And I would suggest that you, again, create some variables that have different values of these types. So types are really, really useful things. And we've seen the type function, which tells us what type does a particular value have, or what type does a particular value within a variable have. And sorry, I'm just looking at, no, before I move on, I meant to ask another Top Hat question, which I am going to do now. And this is another one of those choose a type to represent a particular kind of value. Okay, so what we have on the left are we have a bunch of different kinds of values that we might like to represent in a computer program. What we have on the right are a bunch of different types, and you need to grab the response types and drag them around so that the thing on the left corresponds to the correct thing on the right. So for example, I'll tell you, whether or not you pass a course would not be well represented by a floating point number, so you need to choose what is a better type to represent that. And once you drag those things around, then you should be able to have 6 correct answers, hopefully. So you go ahead and answer that question. So there's a question, how do you reset a variable in Thonny? So if you want to reset all of the variables. Then there is, let me pull up Thonny. If you want to reset all of the variables, this stop button will restart the Python interpreter. And in fact, let's do that now. So I'll start it, and now we have no more local variables. And that can be a handy thing to do if you're not sure how you got where you are. In terms of unsetting a specific variable, typically a more meaningful thing to think about is to put a different value in the variable. So if you have a Python script that you're writing, and we'll talk a little bit more about scripts now in a couple of minutes, if you have a Python script that you're writing in which you have a variable that you're not going to use anymore, well, you don't really need to think about it anymore. It's kind of no skin off your nose if there's still a variable called x floating around, as long as you're not using it. If you are going to use it again and you need it to hold a different value, you can just assign a different value to it. But if you want to reset them all, then this stop button will do that for you. So we've got lots of answers coming in. I'm going to close this now, and if you haven't answered it yet, it will be available as homework. So let me close this and have a look at the responses. And by and large, people had pretty good responses. Mostly people saw that the number of students in the course is an integer number. We wouldn't register 37.5 students for a course. That could be very messy at the door. If we want to measure the air temperature, float is probably a good choice. If you are using any kind of precision, 17.5 degrees, you could make a plausible argument perhaps for only using an integer, especially like if you're in the United States where they use Fahrenheit, and who would ever want to know that it is 97.3 degrees outside. That said, if you're measuring a body temperature, then you would definitely want to know with more precision. So 37.5. Student number is definitely going to be an integer. Student name is definitely going to be a string. Your final grade in this course. So as I mentioned previously, final grades in courses can only be integers. So you can't have a grade on your transcript of 97.8. Instead, we'll just round it up to 98. And whether or not you pass the course is indeed a Boolean thing. It's true or it's false. You can pass or you can not pass. Okay, so we've seen the type function, which tells us what the type of a value is, but also something we might want to do sometimes is to convert values to different types. Now, you might wonder why in the world would we want to do this, and if you figure out why you want to do it, then we might ask how would we do this. Let's discuss these things. So let me introduce you to a new Python function that we haven't talked about yet, and that is a function called input. An input is a function that you can use to get input from the user. That's why it's called input. So I could use the input function, and I'm going to type a little prompt here, which means the computer will ask me a question, and then the input function will get my response. It will get my answer. So I'm going to use the input function, what is your name? And it's going to ask me, what is your name? I'm going to tell it, my name is John. Press enter, and we'll see that this function call, which is an expression, remember, function calls are expressions. They evaluate to values. What this function call evaluates to is whatever the user typed in. And in this case, what I typed in was John. So let me assign that to a variable. So if we say, what is your name? And I press enter, I'm going to say my name is John, and you notice that the value John is no longer printed out by the interpreter because now it's being stored to this variable. So I have a variable called John. What is the type of the value stored inside that variable? Well, it is also John. And then if I say, let's prompt the user, which is just going to be me in this case, what is your favorite number? Now, I have a few different candidates that I might use. Let's say in this case 42. So I have a name, and its type is John. I also have a number that's stored in a variable. And that number is 42. What's the type of that number? Or sorry, I shouldn't say it that way. What is the type of the value stored in the variable n? Let's be precise. Aha, so we have a little controversy here. And as well we should be, because something ever so slightly confusing is happening. And for good reason, the type is string. Because what does string represent? String represents a bunch of characters. A bunch of characters such as the characters that the user has typed in. So I could have chosen to be very, what would the word be? Absurdist or something. What is your favorite number? My favorite number is the number of feathers in a snowstorm or something. Now, that's kind of a weird response, but okay, it is a syntactically valid response. There's no reason that the user couldn't type this. Because remember, from the computer's perspective, it doesn't understand what these things mean. It has syntax. So Python has syntax rules, and it says you're calling a function called input. You've given me a prompt to show the user. The user has typed something, and I've stored that something in a variable that you've told me to put it in. So the only thing that this input function can know is that the user's typed something. And so I need to store that in, and I'm going to give you a value, which you can store in a variable. And that value, the only type that makes sense in that context, the only type that makes sense for keys that a user has pressed on a keyboard is string. However, that doesn't necessarily help us very much if we want to do things like computation. So I have, and this is something that comes up in the very first lab, and so the lab instructor had to quickly show people this thing, and now I'm going to explain it to absolutely everybody. So in the lab, you could input things from the user, but then you have to do something with those things. So if I have, in this example, to get really sort of absurdist, to go back to Monty Python, that classic comedy troupe who did lots of absurd things. If I ask, what is your name, and what is your quest, and what is the average airspeed velocity of an unladen swallow? That's pretty long, but that's okay. Let's go ahead, and I am just going to copy and paste that into Thonny. Okay, so what is my name? And because we're talking about Monty Python, I'm going to be Sir John, and my quest is to teach programming. And what is the average airspeed velocity of an unladen swallow? I'm going to say it's 10.7 meters per second. Now, I don't know if that's actually correct or not. I'm sure it isn't actually. But that's what I'm going to say. So now we might ask a question. So we have a number here. Well, we have an input from the user about how fast an unladen swallow travels. So then we might ask a question like, how long will it take the swallow to fly 792 meters? So someone says African or European swallow. Excellent. So yes, how long will it take the swallow to fly 792 meters? So if we have a speed and a distance, how do we find the time? Come on, first-year engineering students. I have a speed and a distance. How do I find the time? Right, so the time should be the distance divided by the speed. Good. So, if I say that my time is equal to the distance, which in this case I said was 792, divided by the speed, which is in this variable v, then I would like to get a number. But what I actually get is a type error, because you can't divide an integer by a string. That doesn't really make a lot of sense. So what are we going to do instead? So this is where type conversions come in. Sometimes we have a value of a particular type, and we would really like to have a value of a different type instead. And what we can do in this instance is, if I want to if I know that the input that I'm getting from the user, so v is equal to, get some input from the user, what is the average airspeed velocity, which is redundant. You just say, what is the average airspeed? But we want to be faithful to the script. Instead, so I can input that as 10.2. If I want to have a number, I can actually convert that string to a floating point number using the float function. So these types that we've seen, int, float, string, bool, these are also functions that we can use to convert different values into that type. So if I say v is equal to float v, what does that mean? We're going to take the value that's stored in v, we're going to pass it to the float function, and then that's going to give us a value of type float that we can store back in v. And now you'll see that v up here in our list of variables is just 10.2. It's not 10.2 in quotes. And now we will also see that the type of v is float. Another way I could do this, instead of assigning the string that comes from input into v and then doing the conversion, I could actually take this input and take its result and directly pass it to the float function. So what does this do? Well, when we execute this, and in fact, what I'm going to do here, I'm going to paste this at the top. There we go. So, and I am actually going to make this all fit on one line, I'm going to shorten this prompt. So what happens here? Print 792 divided by v. So when I run this script, and I'm going to use Thonny's debug mode so that we can, oops, there we go. I'm going to use Thonny's debug mode so that we can evaluate these expressions one step at a time. So I click the step into here, and it says let's run the input function. So we're going to take this prompt, pass it to input, and then the input function runs, and I say, what is the airspeed? 10.2, enter. And now you see that the result that came back out of the input function was the string that contains the characters 1, 0, 2. Then we can take that string and pass it to the float function and say, dear float function, can you interpret this string? I've got a string that says 1, 0, 2. Does that make any sense to you? And then the float function will convert that into an actual floating point number, which is 10.2. So we've now stored that inside of the variable called v, and now we can print what is 792 divided by v. Well, let's print 792 divided by v is 792 divided by whatever value is currently held in the variable v. We go look in the box and we see it's holding the value 10.2. So this is 792 divided by 10.2, and that is 77.64. So we'll pass 77.64 into the print function, which will cause that number to be printed, 77.64. We can also run that more quickly, and I say if the average airspeed velocity of the Swallow is 578.3, well, then you see the Swallow takes a lot less time in order to fly 792 meters. But that would be a very, very fast little bird. Then, so we have a question. What if it doesn't make sense to float? Yeah, that's a really good question. So if I say, dear float function, can you figure out what 1.23 means? 1.23, and the float function can say, yes, I very well understand what that is. That's the number 1.23. If, however, I say, dear float function, can you make sense of the number 1 greater than 15? We're going to see that the float function gives us an error, and it says you've passed in something that is not something I can validly convert to a float. I don't understand what 1 greater than 15 means. So we can only pass in strings or other values that can be converted to a float. And we can convert lots of things in this way. So we can have a float of 1.23. We could convert 17, the string containing the characters 1 followed by 7. We could convert that to an integer. We can actually even combine these things. So let's say, what is the integer value of the float value of the string 1.23? So what will this do? Well, let's try it and see. So we'll use Thonny again to step by step break apart these expressions as simply as possible. So we're going to print int float. Well, what does that mean? Well, order of operations, we're going to go to the inside first. So what is the value we're going to pass as input to the float function? It is a string that contains the characters 1.23. We pass that into the float function, and that's going to give us a result. What result will that be? It'll be 1.23. We take that floating point value, 1.23, and we pass it as input to the int function. And we're going to convert 1.23 to an int. Well, there's one sense in which we kind of almost can't do that. You can't convert 1.23 to an integer, but what you can do is get an integer out of it with loop, but you're losing a little bit of information. So these kinds of type conversions can sometimes result in us losing information. So what is the integer part of 1.23? Well, it's just 1. So then we take 1 and we pass it to the print function, and we end up printing 1. What about this? What is this script going to print out? There's an excellent question here. If we convert float to int, what is rounding going to be? That's an excellent question. So what do you think this script will print when I run it? And there's a couple of different answers that would both be plausible with what we know so far. So don't feel bad if you get the wrong one. We've got some 1s and we've got some 2s, and they both seem pretty plausible. The answer is 1. And the reason for that is the int function, when you pass it a floating point number, it gets the integer part of a floating point number. So if you have 1.9999999 and you say, what is the integer part of that? Well, the integer part of that is still just 1. If you want to round things, then we can use a built-in function called round. So 1.9 will be rounded to the number 2. So type conversions are super, super useful. Speaking of useful things, you'll notice that once I started typing things like get the input from the user of what is this airspeed and convert it to something else and then print that out, I didn't really want to have to type that over and over and over and over again. And this tension came up in the lab with students on Monday and Tuesday, where we asked you to open a Python environment and to type an assignment statement, and then to type another one and type statements over and over and over. And some of those statements were actually the same thing. Like you might say, I'm going to turn this knob here, and then I'm going to tell Python, please read from this potentiometer, convert that to something else, play the buzzer, stop the buzzer. Now I'm going to turn the knob here, and then I'm going to say, dear Python, read from that potentiometer, calculate a frequency, play the buzzer, stop the buzzer. And this gets kind of tedious and repetitive. Over and over and over again, rewriting the same statements, that's tedious. And programmers hate tedium. We are lazy in a good way, which means that whenever we find ourselves doing the same thing over and over and over and over by hand, we think, there must be a better way to do this. There must be a way that I can automate this so that we don't have to manually do the same steps over and over. We could get a computer to do this over and over for me, because computers don't mind doing tedious, repetitive things. And so here is the script mode of programming. And I've already kind of showed you this a little bit, but now we'll look at it in a bit more detail. So I've already showed you in in Thonny, sometimes we talk to the interpreter directly. And I say, what is 1 plus 1? And sometimes I work up here in this little box where I can save a file. Well, that file is called a Python script. So let me just copy and paste my script into this box. And Thonny is not letting me resize the shell, so that's fine. I'll just close the shell for the moment. So here I have a Python script that has a bunch of different stuff in it. And you'll note that this is doing kind of the same thing as before. So we said, let's input your name, let's input your quest, let's import the average airspeed of an unladen swallow, and then I'm printing some stuff. So let me change, so the print function can be used in a bunch of different ways. One of the ways that it can be used, we can actually pass multiple values to the print function, and it will just print them all with a space in between them. There are also, let's avoid f strings for now. We'll talk about f strings later. Okay, and so we can pass multiple different expressions to print. So just like before, I input some information here. I print something now, like I say, greetings, brave, whatever your name is, brave dame, brave knight. And then we do that conversion that I talked about before. And then we're going to print some more information that uses some of these values in expressions. So I'm going to run this script. What is your name? My name is Sir John, and my quest is to educate the, and I'm going to use too many capitals because that was kind of an historic thing, to educate the fine people of NG 1020 and the average airspeed of an unladen swallow. Let's say it's very slow today. It's 0.5. And then you see my script does some stuff. It says, greetings, brave Sir John. Your quest to educate the fine people of NG 1020 will be aided when the swallow flies 792 meters, and this should take 1,584.0 seconds. Now, instead of typing all this stuff over and over, if I want to run the script again with a different name, my name is Bob, and my quest is stuff, and the speed is 1. Well, now notice I didn't have to type statements over and over. I just ran the script again. And so this is a very common mode of programming. We write a script, we run the script. So you only have to write it, ideally, once. Sometimes you find errors and you have to go back and adjust it. But ideally, we would write a script once and run it many times. We see this with Gradescope when you upload exercises, where you write a script, you upload it to Gradescope, and then Gradescope will run it with this input data, and this input data, and this input data, and a bunch of different test cases. So what do we see in here? Well, we see a bunch of things in this script. We see comments, copyright, type conversion, and variables. So what are comments? So comments are these lines in Thonny that start with, well, the symbol is called an octothorpe because apparently there was a fellow named Jim Thorpe who was tasked with naming that symbol on a telephone back, and he worked for AT&T Labs or something, and he called it an octothorpe because he was called Thorpe, and it has 8 points. But people will call this a pound sign or a hash, or sometimes people say hashtag, hashtag copyright 2020 Jonathan Anderson. And that's because I wrote this in 2020. But a comment is some helpful descriptive text. See, here I'm describing greet the brave dame or knight. Here I'm saying convert speed into a floating point number and calculate quest time. These are helpful comments that I'm putting, but they're not for the computer. They are for people. Because people will spend more time reading your code than the computer will. So when we write source code, whether it's a Python script or a C++ file or whatever kind of programming, whatever kind of code we're writing, it needs to be intelligible to people. Those people could be a work term student who comes along after your work term and they have to maintain the work that you wrote. It could even be yourself. You write some code at the beginning of a course and then you're working on other things to do with your project and you come back to it at the end of the course and say, what was I working on there? You want to have things like comments that explain, here's why I'm doing things the way that I'm doing them. And so a comment, syntactically, is everything from that hash sign or pound sign up to the end of the line. The computer, Python, will just completely ignore it. It's for people. Another thing you see here is copyright. So believe it or not, writing code, it's more like writing English than it is like writing math assignments. So writing code is a creative act, kind of like writing a screenplay or writing an essay. It is a creative act, and in fact, it's protected under the law by copyright, the same as other kinds of creative act. You can't copyright math, but you can copyright a novel. You can't copyright math, but you can copyright source code. And in fact, whenever you write source code, by default, it's implicitly copyrighted, even if you don't say so. And so sometimes when I'm giving you code exercises, I will in fact deliberately say things like, you have permission to do blah, 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 blah. Because if I didn't say that, then legally you wouldn't be able to copy that code. And that's how copyright works. So copyright is more like an English assignment than it is a math assignment. So you've already seen variables and floating point or number conversions and stuff. So what should you do next? After this, you should write a Python script. Write a Python script that will take some input from the user, use that input function, that will compute something, anything you like, and produce output. And this will be really, really good preparation for exercise 2. Which should now be posted. So in exercise 2, I would like you to prompt the user for their name and their age, and then print a string telling them how old they will be on today's date in 2030. So actually, this number might not be correct anymore. Yeah, this should say, sorry. There's an off by 1 error because I used this exercise last year as well. But that is exercise 2, which is going to be due on Monday, so it's not going to be due on Friday. I give you a little bit of extra time to do that. But I want you, before you even attempt that exercise, just by yourself, write a Python script that takes some input from the user, computes anything, whatever kind of expression you like. Maybe make it be related to your physics course or your chemistry course or something. But take some input, compute something, and produce some kind of output. And then attempt exercise 2. And once again, these exercises, please do them together, learn about stuff together. You can screen share in WebEx or create a Discord, or there are all kinds of ways that you can do screen sharing and virtually doing things together, or send stuff to other people by email, etc. And of course, once we get into classrooms next week, we'll start getting in even closer quarters where, it'll be possible for you to sit in a classroom next to somebody and say, I was working on this. What did you get? Or talk to somebody who's in the lab, and maybe we'll start having lab partners again soon. So that is it for today, which is good because we're 3 minutes over. Sorry. Any final questions that people have? Okay, looks like there aren't any questions, just people saying thank you. Well, you're very welcome, and thank you for coming. And I'm looking forward to meeting more of you as we finish up labs this week, and then hopefully we'll even have some opportunities to have some kind of interaction, whether it be office hours or whatever, as the semester goes on. So thanks very much, and I hope you have a great rest of your day.